Well, welcome to this webinar on air quality and air filtration selection. I'm John Figgins. I'm the technical specialist for food with the BRC Global Standards. And with me today are Ross and James from CAMFIL. Now, for many years, the BRC Global Standards have contained requirements for air quality. For example, in clause 8.2.2, there's a requirement for high-risk areas to be supplied with sufficient changes of filtered air, and the filter specification and frequency of changes of those needs to be based on a risk assessment, taking into account the source of the air and the need for positive pressure in those areas. However, the standard has never been prescriptive on the type of filter that should be used, because as mentioned, that will depend on the risk to the product and the source of the air. However, we have with us today our colleagues from CAMFIL who are going to explain how to decide what filter is correct for you and why that is important. Thank you.
Thank you, John. My name is Ross Dummigan, and I'm the Food and Beverage Segment Manager for CAMFIL, with responsibilities for continental Europe and British Isles. What we're going to do this morning is go through the new BRC Global Standard in relation to air quality and air filter specification. The agenda that we're going to look at today is we're going to look at indoor air quality definitions, the new BRC Global Standard for air quality and why we have this. We're going to look at air quality standards, a brief history. We'll speak about compliance. We'll also discuss ISO 16890, EN 16798, Eurovent RS4C 001-2019. We'll touch on molecular filtration guidance. We'll speak about risk mitigation and maintenance and condition monitoring. So, indoor air quality definition. Indoor air quality refers to the quality of the air inside buildings as represented by concentrations of pollutants and thermal conditions that affect the health, comfort, and performance of occupants. Here we see a typical setup of an air handling unit. As we can see from the arrows, 1, the air is coming into the air handling unit, is untreated. At arrow 2, we can see it is passing through a filter. At arrow 3, the air is passing through a heat exchanger. At arrow 4, the air is supplied within the production hall or the room. Arrow 5, we're speaking about exhaust air from the room, so from the production halls or from within the whole production process. Arrow 6, the exhaust air is being filtered through classified air filter in one of several filter steps. 7, passing through the heat exchanger. And 8, heat exchanger air returning outdoors or being recirculated. How does air quality impact on production? Air quality can impact on production either with having poor air filtration. It can impact on product contamination, employee health, odor emissions affecting general public, product shelf life, labor costs, production costs, and energy costs. With the new BRC Global Standard, Air Quality Standard, we discuss why we need these. And in relation to compliance, we also have referenced within the document ISO 16890, EN 16798, Eurovent RS4C 001-2019. Within the document, we showed the options for easy filter selection. We speak about standardization, and we also discuss transparency. So, why develop a new global test standard? What are the customer benefits? Recognition. Air filters positively influence air quality, food production, shelf life, and human health. The standard is more intuitive. Filter efficiency and classification are aligned with real-world air pollution. Global applicability. It eliminates confusion. The standards referenced within the document are global standards, so they're applicable at every location. What are the benefits for the industry? It gives everyone a level playing field. We've got fair product comparison. We drive product development, drive innovative and customer value, and especially eliminate low performing products that are used within the food and beverage industry. The global standard means there is one test for all producers. It removes obstacles to global trade. Simplicity. It's easier to explain product value in terms of function and application. So now we're going to look at just a brief history on standards and how far they've come. First, we're going to look at filter standards for general air filters. We had CN 779-2012 and ASHRAE 522 for the Americas. Now, within Europe, CEN 779-2012 has been replaced with ISO 16890, which is a global standard. It refers specifically to PM1 values of filters and is all about air quality and indoor air quality. Filtration standards for HEPA and OPA filters use the standard EN 1822-2009, which is still in effect today. Energy and environmental standards Eurovent 421 and Eurovent RS4C 001-2019 are in effect, which cover the efficiencies of the filters and also the energy consumption of the filters. Now, the important point to note here is you cannot be Eurovent certified if you are not compliant with ISO 16890. So this is why when we're speaking about filter certification, it is always important to ensure that the filter provider can provide the certificates to ensure that compliance is being achieved. When we're speaking about compliance, within the document we reference ISO 16890-2016. This refers to air filters for general ventilation. Part 1 speaks about technical specification requirements and classification systems based upon particulate matter efficiency, or EPM1. This is the new standard for testing of air filters. And from July 30th, 2018, this replaces EN 779-2012 and provides a much better test with a clearer classification system. The test has been developed and improved over the previous test methods to ensure that reported efficiencies represent the real-life performance much more accurately than the previous test method. EN 16798 refers to energy performance of buildings, ventilation for buildings, for non-residential buildings, performance requirements for ventilation and room conditioning systems. This standard gives much needed guidance regarding the performance of ventilation systems and the requirements for ensuring the required air quality is achieved. It also provides a clear link to outdoor air, ODA, and its impact on indoor air quality with guidance on the air filtration specification required based on the ODA. So let's discuss EN 16798. EN 16798 splits outdoor air quality into 3 categories: ODA 1, ODA 2, and ODA 3. These are based on the World Health Organization annual mean limits for particle sizes of 2.5 micron and 10 micron. Currently, the WHO limits for air quality are used as the basis for establishing the 3 ODA categories and are as follows. The annual mean for PM 2.5 is categorized in 10 micrograms per meter cubed. The annual mean for PM10 is categorized in 20 micrograms per meter cubed. From these values, the 3 ODA air quality categories are as follows. ODA 1 applies to the WHO 2005 guideline, and any national air quality standards or regulations for ODA air are fulfilled. ODA 2 applies where pollutant concentrations exceed the WHO guidelines or any national air quality standards or regulations for outdoor air by a factor of 1.5. ODA 3 applies where pollutant concentrations exceed the WHO guidelines or any national air quality standards or regulations for outdoor air by a factor greater than 1.5. So how do we establish the outdoor air? Governments and environmental authorities around the world monitor air quality. The data for this can normally be found on national, regional government websites. And for an example of this, we've taken the DEFRA website within the UK. Using the website, we can view historical data for air quality monitoring for these particle sizes, PM2.5 and PM10. We can see the PM concentrations from the map on the right-hand side of the page. To get this information, what we need to do is we need to select the roadside in the data type, select either PM2.5 or PM10, select the most recent year that's available. As we can see on the picture, we selected 2017. Enter your postcode, and at the bottom left-hand side of the page, you can click on the zoom function and it will zoom into your location. The definitions for the ODA categories as set out earlier as follows: ODA 1, ODA 2, and ODA 3. This is the results that we will see from the local websites. These websites are managed by local authorities and NGOs, so the information is freely available within every country.
So what we're going to look at now is EN 6798 and Eurovision 421. As we discussed earlier, air filtration should be based on two factors: outdoor air and supply air. Governments and NGOs monitor outdoor air quality, and as we've seen in the previous slide, the outdoor air can be ascertained by checking these types of website and databases. Food and beverage facilities are specifically referenced within EN 6798. This provides clear instructions for filter selection for manufacturers and auditors. And as we can see below, the standards have broken it out in from supplier 1 to supplier 5. What we've put into the document as well is this table, which shows the category for outdoor air 1 to outdoor air 3, and also supplier from supplier 1 to supplier 5. What's important to note here is supplier 2. And the reason for that is food and beverage production is specifically referenced within supplier 2. So what this tells us is that the quality of filters that we use for high care, high hygiene, and high risk zones should be at minimum EPM1 50%, all the way up to EPM1 80%, depending on the outdoor air quality. Within supplier 3, basic hygiene and low risk food and beverage production are also referenced. So what this tells us is that low risk and basic hygiene filters should be at minimum EPM 2.5 50%, and at best EPM 2.5 80%. This gives us clear guidance and clear instructions for the type of filters that should be used within a food and beverage production facility for both manufacturers and for auditing purposes.
Eurovision 421 and now the new Eurovision RS4C 001 2019 give us clear efficiencies and energy consumption that filters need to achieve, so that the filters going into your plant are energy efficient and provide good levels of air quality. The table on the right hand side of the page shows the classification of the filters within the EPM1 values. So what we see is the energy consumption limits for EPM1 filters, EPM 2.5 filters, and EPM 10 filters. And the classification for these filters go from A+ all the way up to E. And suffice it to say, the best filters that can be used are EPM1 A+, which means that you have your high level of air quality from EPM1 filters, but also you have A+ rated energy consumption filters, which means that you have the lowest energy consumption of the filters within your air handling units. This is the type of label that is on compliant filters. This label will be on the boxes and it will be on the filters. So if anyone is purchasing filters, these labels should be on all the boxes being provided to sites. Now, filter manufacturers as well as filter providers should be able to provide this certificate and this label on their filters if they are compliant. If they are not compliant, then they will not be able to provide this. This is why it's important to demand this from any filter supplier coming onto your site.
Certain contaminants are present within the air which standard particle filters cannot remove. Two examples of this are nitrogen dioxide and sulfur dioxide. There are others, but for this presentation, we've just referenced these. Within the table below, we can see the criteria for which molecular filters are required and recommended when we classify them against outdoor air and supply air. What's important to note here when it comes to molecular filters is that they should be used as third stage filtration or second stage filtration. And the reason for this is we need to have pre-filters taking out any particulate that can contaminate the molecular media so that it is utilized correctly. There is no point putting molecular filters at first stage because it will become fouled and will not work.
When we're speaking about risk mitigation, let's look at the considerations. Most filter manufacturers offer a range of products varying in specifications, and some are tailored to suit different segments. Therefore, whenever possible, you should confirm the following when selecting filters. Has the filter been tested to the current standard, ISO 16890:2016? If so, the filter manufacturer or filter supplier should be able to provide you with the relevant test reports and certification for that product. Does the filter have specific certification and attributes that makes it suitable for the food and beverage industry, such as certification to EC 1935, VDI 6022, and or ISO 846. This means that the product being provided is completely safe and suitable for use within a food and beverage facility. Is the supplier technically competent? This is something that is very prevalent and very relevant for us within the food and beverage industry. Obviously, air quality is a very complex issue and a very complex topic for discussion. And you have to deal with professionals that know what they're speaking about. And dealing with these type of professionals is invaluable. Do the filters carry labels from the manufacturer, not necessarily the supplier, that can be used to verify compliance once they have been fitted? All filters should carry such labeling. As I've said in the previous slide, especially with the Eurovent certification and labeling, all filters being supplied to site must carry the manufacturer's label, not the supplier's, the manufacturer's label. This is the only way to actually clarify what filters are in use and if they are compliant. This allows us to go on and check independently the certification on the Eurovent website as well. Maintenance and condition monitoring. What we've seen within the industry are these pictures and the conditions of air handling units, ductwork, fans and coils. Suffice it to say, they are in poor condition and poor maintenance condition. Now, to mitigate this happening, within the document, we reference motor fan condition monitoring. We speak about AHU cleanliness and ventilation hygiene risk assessments. We reference glass traps being fitted to monitor mold and bacteria growth. Checking coil condition and the cleanliness of your coils is very important. If your coils are becoming foul or are dirty, then it obviously impacts your heating and cooling costs, but it also impacts your energy costs. Filter frame condition and the condition of seals within an air handling unit. If the seals that the filters are being fitted into are not supple and soft, then you have the risk of bypass. And the same goes for the doors and frames within the unit. These should be regularly inspected. Pulley and belt alignment and bearing conditions are of vital importance for the efficient running of your air handling unit. Probably one of the most important is the pressure gauges. We need to check are they working and calibrated within the last 12 months. The most efficient time to change filters is basing it on pressure, not time. And having these pressure gauges calibrated and being regularly inspected gives us the visibility on how the filters are performing and when they should be changed. As we can see from section 6 within the document, we have referenced these topics and many more that gives clear guidance on what needs to be done to maintain the air handling units. So to summarize, when we're speaking about HVAC filter compliance checklists, filters should be compliant to ISO 16890. Your filter should be certified to Eurovent 421 and RS 4C 001 2019. The Eurovent labeling on the boxes and on the filters will verify this. And this is why it's always important to check the filters when they come into your facility to ensure they are compliant. The filter should be certified to ISO 846, antimicrobial growth certification. They should be certified to EC 9035, suitable for food contact. The filter should be certified to VDI 6022, that provides full hygienics to the products and production within the HVAC system. The filter should be free from all harmful components, and the product should be fully traceable. All components of the product should be fully traceable. So, now, if you could fill in any additional follow-up questions that you have from the presentation, John and I will compile these and respond to you in the next couple of days with the answers to these. Thank you very much for attending this webinar. If any of you have any follow-up questions or would like to arrange a site meeting, please feel free to contact me on my email address or contact John at his email address below. Thank you very much for your time, and we look forward to seeing you out in the industry.